All right, microphone on. Awesome. Let me reset this clock. All right. Thank you, Circle City. Thank you for staying through to the last talk of the day before you guys have dinner and come back for the party tonight. This is actually my first time at CircleCityCon. First time in Indianapolis, so awesome to be here. So basically, some of this talk I want to talk about this afternoon is some research that I was in charge of in doing for Carbon Black. So this is going to be mostly research related, nothing product, nothing vending, and all that fun stuff. But to give a little bit of my background coming into this is that, there we go. I worked on this ransomware project for about 15, 16 months straight, to the point where my coworkers actually made domain names and started like making memes of me throughout the company. I've become known as just Mr. Ransomware, because every time it popped up in like a help channel or customer, it just went straight to me, which I hated. But I had to take over the role. But I'm a senior threat researcher with Carbon Black in our threat analysis unit, we'll call it TAL, which is basically focusing on malware attacks, reverse engineering, just writing up things what we see in the wild and figuring out how to protect against them. Part as well as my background has been about 17 or 18 years now in digital forensics, incident response, a whole lot of different roles. Now I'm actually a stay-at-home, no travel, research, it's great. I'm done with the IR life, but also was a former intrusions analyst for DoD as a contractor, focusing solely on APT investigation. So there's a lot of things that go into my experience to help me do my analysis. If you guys know Jason Street, everyone knows Jason. I'm his co-author on his Dissecting the Hack books, which we have 2 out, and he's working on 3rd now. Also a very valid CTFer, a very rabid CTFer. So this right here is the actual Labyrinth CTF from Palo Alto, where they gave you a die-cast Szechuan sauce as a prize. So that's actually framed in my office as one of my prized possessions. This was before McDonald's brought it back out. So I love that thing so much. So what are we talking about? The idea of ransomware that's not real, that's fake. It doesn't actually exist, yet it pretends to be. So what we'll be talking about over the next hours, it's going to be like very fast-paced talk, a lot of fun stuff in here, some funny stuff, some that may be mildly offensive. So I'll just give you a warning up front. I've censored out a lot of content, just put blocks over it. But if there's something that's sensitive to you, then feel free, you can close your eyes or just walk out. I won't be offended. And kind of start off is this guy. I don't know if you guys have ever seen him. This is Thomas the Train, ransomware sample that really wants to see naked pictures of yourself to give you a decryption code. That's just to set the stage of what we're going to talk about. I'm going to go more into depth of this in a few more minutes, but the idea of outrageously shocking ransomware or just really weird stuff that just doesn't make any sense. This is not your wide-scale Tesla crypt or Petya or whatever. This is kind of off-the-wall stuff and attacks certain types of people. And really the stuff works is because we do have a precedent set in the industry of early ransomware had to infect, had to use strong encryption, had to use AES, had to use a proper private and public key that was sent off to a CT server, because people knew there was no way I'm getting my data back. I had to make that payment or I would be losing my data, I'd lose everything. But now that that precedent's been set, and it's been a few years, what we learned is they don't even try anymore. So adversary just had to write a program to say, your files are being encrypted right now, and you'll still pay, even though they don't do anything. So a lot of them are just screen lockers. They basically just close your screen and you can't do anything. It says, we're encrypting your files. No, they're not. So that's where a lot of this comes in from. When I talked about 16 months of research I did, it was predominantly because we were really focused on proving that we had a ransomware protection knocked down and it was actually working. So it was basically 3,000 samples, 300 plus families of ransomware that we just threw at it, me and a coworker. And as we're going through them, we're doing our typical research stuff of, okay, this sample starts encrypting from C root, this sample starts the desktop, this sample starts from the C users, this one uses AES, this one uses XOR, this one only does JPEGs, so that type of breakdown. And then we have this weird other category, where it's like, this doesn't really fit the mold of actual ransomware, we're just gonna stick it over here. And as we start going down 3,000 plus samples, that other category just kept getting bigger and bigger and bigger, to a point where it's like, that actually is really cool just to dig in by itself. And that's what's leading to this. when we look at those as well, they kind of break down to multiple markets. So consumer and enterprise. Consumer is actually a more fun one, we're going to talk about here. But the reason why these get infected is because consumer relies upon gotcha ransomware, as in you did something bad and now you're in trouble for it. You went to porn sites, you downloaded game cheats, you did a trainer game software somewhere, and now you're going to pay for it. So you get it because you downloaded something you wanted, not something you needed, and by getting that, you actually infected yourself. And the payment is pushed through as a risk of exposure. Either you do this or we're going to tell people about you, or the FBI has a note on you right now that you will be reported if you don't make this payment. Versus enterprise, which is a completely opposite way of doing it, where the infection is through social norms. As we know with phishing campaigns, is that an invoice is being sent to a finance officer, a resume is being sent to an HR representative. They open the attachment because they're supposed to open the attachment, and they get infected. So they get infected because that's their job to get infected. It's your job to stop it. But the judgment that comes in there is urgency, as in, this is a very critical payment, this is a very critical document, you got 24 hours to open this up and respond to it, you need to do this right now. And there's a whole line of attacks and actual ransomware that focus on that urgency as well, to make sure that you do get infected quickly. And the reason of payment is through obvious lack of recovery. They expect you to pay because they don't expect you to have backups, which they're actually always right. Yeah, almost no one has backups. At least no one has comprehensive backups to recover from the attack. So that's how they get your payment. And when we talk about urgency, I love this guy. This is T-Blocker. This is a sample that says, hey, you've been blocked. You've got 24 hours left. Not just 24 hours, but at the expiration of time, all your files will be made public on the internet. And your PC would be permanently locked. Yep, exactly. They actually have all your files. Like, oh, I'll just go to Pastebin, pull them all back down. Yeah, they don't actually take your files. There's actually none of that functionality is actually in the program itself. But they tell you, you got 24 hours to make this payment, or else this. That won't happen. But you know how much money they've made? A lot. Because it's just that fear that it could happen to you. So that leads back into Mr. Tom's the Train here. Love this guy. So I've blanked out a lot of words, but the overall message here is that you are infected, your machine's being encrypted. The only way to get your access back is to send an email to us, and we'll give you an unlock code that you can type in here and get your machine back. The actual terms of the agreement are that you must send at least 10 nude pictures of yourself to get the code back. And those pictures will be sold onto the dark web, or they call it the deep web. And that's how they're going to make their money. Obviously, this is something we're going to laugh. We see this, we laugh, right? As people in this industry, there's no way this could be true. No way people should be afraid of this. However, send news, no bitcoins. In ransom demands X-rated photos. Tom's guide. Tom's a Train wants to see you naked. Kaspersky. In ransom that demands your nudes. Motherboard, ransomware demands nudes instead of Bitcoin. It was inevitable. Really? I didn't expect that coming. But, all right, I'll roll with it. So for everything that we look at, it's like, this is no way. This is not possible. There's a lot of public, freak out that, oh my God, this is real. It's going to be attacking me. And then, suddenly your parents call you up or some uncle and says, is this real? Is this something I need to be focused on? Because they think it's actually going to happen. And really, when we take a look at that binary, for example, these are the files it drops. And one of these things is showing you this may not be a professional adversary. I don't know, you can take your pick. That's actually the Thomas the Train theme song that drops out of that. And it plays as it's got your machine locked. So I won't hum along, but people know what it is, right? Yeah. So you look at that, it's like, okay, this is really a joke. There's no way. But then you actually start reversing it and doing analysis of it. I'm going to have code up here. Don't need to know code. I'll just walk you through what this stuff means if you don't know how to read it. This is a dark background because of the program I use. It only produces dark backgrounds until I fix it. But the overall thing here is that when you type in the code and you click to unlock, it's taking that text, changing it to a double value, an integer, and saying, does it equal 1, 2, 3, 4, 5? That's it. So that's your encryption right there. So obviously not something that we saw prevalent in the wild, something that was probably either targeted or we call it proof of concepts, as people showing off the street cred or what they could be doing. However, when that stuff does hit the limelight, it just lights up like crazy. And people get really worried about these things. To the point where this was September of last year, as Kevin mentions here, that nude ransomware, which isn't even in the wild, has more press coverage than CC Cleaner. You guys know what CC Cleaner, right? It's like that was a major APT attack that targeted hundreds of thousands of downloads of corporations. They only picked like 20 or so, but there's hundreds of thousands of people infected by that. Yet that had nowhere near the press coverage as this stupid ransomware. You think, okay, it's just a one-off. One of those. Actually not. There's a whole family of these. Probably written by the same guy. He keeps cranking them out every now and then. About 2 months ago, we came out with this guy. Autism Locker. Lots of bad words up here, so don't read out loud. I'm not going to read out loud either. However, there's some few weird things in here that do tell us, hey, maybe it's the same guy. Send me 15 of your nudes, or record yourself gunning down innocent children. Wow, okay. Send the recordings to that offensive word, and we'll make sure you kill that and that more offensive stuff. Basically 4chan style ransomware. And when we look at this, like, okay, is this related? Yeah, you look at the code, it's definitely exact same code. 1, 2, 3, 4. 1, 2, 3, 2, 4, 3, 5, 4. It's like obfuscated now. This is actually real code now. The weird thing about this, actually not weird anymore, if you know programming languages, .NET, C, C++, so forth, 95, 98% of all ransomware is in .NET, which is surprising to me because most malware is in C or C++, but ransomware is like almost all .NET, which is not prevalent in like APT stuff. That's used like Iran territory in like one of those countries, but here, mostly because it's so easy to write in. There's so much code on the internet already, you can just copy paste it. The good thing about it for us as analysts is that there's tools out there. This is a tool called DNSpy that lets you just dump it. Like it just displays the code for you with very little effort. So basically I just load this executable in there, click a few buttons, and that's it. It just pops this out at me. There's a few obfuscators I'm going to show you a little bit later on, but that's pretty much all the effort it takes to really dig into these applications. So yes, this is a weird family. This has some really funny stuff to it, and it's prevalent. We still see it coming out. Really not in the wild, it's actually infecting people. But then we start seeing things like Annabelle. Have you guys heard of Annabelle, the actual ransomware? A few people picked up on this. This is about 4 months ago. Basically, based off a horror movie, this is great. It actually infects your box. It is completely destructive. It will encrypt every one of your files. It will disable the start menu. It will disable task manager. You can't do the start, Windows R. And then it will overwrite your MBR. Does everything. Before it gets to that last step, it will actually show the screen and then start playing music. And you can imagine it's creepy, creepy music with a video or actually an audio of like a little child laughing, like very sinister, insidious laughing. To the point where this was it Labor Day, Memorial Day? I was actually out camping with my kids in a cabin in the woods, and I'm sitting there working. It's a 3-day weekend. I'm looking at some ransomware. We go out. I've run this off. I'm like, okay. Usually when I run something, I just let it run in a sandbox, give it about 60 minutes to marinate, and then come back and look at the results. So I kick this off, walk out the door, we go hiking, come back in. Kids, as he would come in, he's like, I want to be the first inside the door. He runs up, goes in the cabin, comes out crying. Like, what the hell? There's like someone laughing in our room. It's like, it's like, yeah, that's kind of funny. So he did not find the humor in it. I laughed so much. But basically, they build this whole theme to it. They make an experience out of it. You're not just getting affected, you're being experienced in this thing. However, this thing again, when you start looking at the actual ransom note, the dark sites are not existing. It's just an example text. All right, so proof of concept. All right, Guy's trying to show off his chops, see how good he is, so he can actually start building and writing better ransomware. Other things we saw when we ran this is that before you actually, well, as soon as you click on the executable, this is the pop-up, basically saying, warning, do you got .NET 4.5? If you are not running it with 4.5, then the Trojan won't work. Seriously? Seriously? I did try both 4 and 4.5, and it got to work both ways. So, like, okay, obviously this is nothing. We don't need to worry about this. However, no, apparently we do. Because article after article came out of, oh my God, Annabelle, the scariest mother encryptor ransomware you should be worried about. Literally, that's the problem, right there. In one article. A horror show for users. And I love this. Newly discovered variant Annabelle is seemingly designed to wreak as much havoc as possible. Yeah, in a sandbox in theory, not really, like it's not hitting your box. But it left this like just bad taste of, oh my God, there's so many threats on the internet trying to kill me right now. So many families of ransomware that we should all be afraid. Not really. And it gets more fun from there. Let's take a look at Hi Buddy. It's a Hi Buddy, because it actually says Hi Buddy, so we call this Hi Buddy. That's the actual family. Most of them are actually ransomware. This one will encrypt your files, does the fun stuff. It actually loads up an IE Explorer frame, does Bitcoin websites like, hey, we're going to walk you through how to buy Bitcoin and give it to us. They actually have all these buttons. What are Bitcoins? How can I buy Bitcoins? Search Google for Bitcoins. Help me. We actually connects to the support channel. So they're very nice about this. Very, very nice people. And it even says, okay, yeah, here's your onion sites, your files being encrypted. However, we've also seen variants of this, such as this one, where it actually, they forgot to put the encryption code in. So you could just hit Alt F4. Like, that's kind of anticlimactic. But, every now and then we see people get really freaked out and like, no, don't worry, try this. Hit Alt F4, see what happens. Oh, it's gone? Check your files. Oh, you don't see it encrypted? Oh, you're good to go. Don't worry about that. Here's a consulting fee. There's a whole lot of things like that. We're called screen lockers. So screen lockers are a thing, but when they pretend to do or pretend to say they're encrypting to put that sense of urgency in you, that's where it starts not playing nice. This is Lambdalin. Your Windows has been banned. Dear Windows user, your PC has been banned. We're sorry to say we are now hijacking legally to your computer. I don't think that's how it works. Maybe, I don't know. And we are now trying to lock your files because of fake Windows. To know more about this kinds of ban, visit Microsoft.com. Oh, okay. That's very nice and helpful. And you click on this, hey, but we have a solution. Yes, to unlock PC, you can do two things. You have to play us in order to unblock or whatever. We will delete your files now, unless you do this. So $200, send it to the PayPal to this Microsoft Zyber. They just changed the C to a Y. Very clever. Love that. Actually, when you look at the code of this, there's no deletion code at all. There's no encryption code. There's nothing. It just pops up these dialog windows and blocks your screen, and then that's all it does. Now, that's when you can't Alt F4 out of, but again, it gets that fear, and you're like, oh my God, like I need to do this quick, and it's cheap. Quick and cheap. I can do this right now. I can just send a quick PayPal and get my data back. But it doesn't actually do anything. So that's the whole psychology of this is if you make it cheap enough and you really panic people out and you make them think that, okay, you're about to lose everything in 24 hours, people will pay. And you don't actually have to do anything. Like the level of effort to just make this window versus actually making code that has to work, you have to test it and QA it and do support on it, nah, it's too much work. So what do you have, obligatory Rick and Morty reference, just like Szechuan sauce. What do you have in ransomware that actually does work, but not so well? That's what we call being shot with rubber bullets. Yeah, it hurts, but you can just walk it off. There's not something that actually is going to destroy your business. And there is actually quite a lot of ransomware out there like this. either buggy or just broken in many ways, or just so badly written that you can decrypt it, which is like a junior intern engineer can look at a code and be like, I got that. You write your decryptor. This guy, Thomas the Train, remember this guy, right? So you remember you type in a code into this box, you hit unlock, and it unlocks your box. Weapons, it wants a number, 1, 2, 3, 4, 5. What happens if you don't give it a number? What happens if you give it a word? It will crash your box. I forgot to censor out that one word, but it will actually crash, not the box, it will actually crash the application. So it basically just closed it out by typing in a word instead of a number, because they didn't have any error handling around that, which is awesome. This is why we do all this type of work. But that idea is still set in the groundwork. When people look at existing ransomware code on the internet, this is a copy of dumb, D-U-M-B, that's actually what it's called. It actually is pretty dumb. So this is a framework you can download, it's open source, and you can use it for your ransomware. It uses basically simple XOR encryption. But the way they hid the actual key that was used to encrypt your files is by converting a string to hex values and putting them here in this weird thing. That actually just says test key. But that's as far as they wanted to go in actually obfuscating their encryption. No AES, no private key, no public key, just a single word, and they use that to encrypt every file on your hard drive. Once you know that word, you can just get it right back. It's actually pretty easy. And we see that exactly a lot. So in this, code, don't worry about this. What we see in this one example is it's actually doing a simple XOR as well. There's actually a routine that they call XOR. Give it the text of the file, give in the password, and it'll just do it for you. This one actually is pretty nice. This one is, I can't say the word, extremely offensive. But this one actually does time stomping at the end. After it encrypts your files, it'll time stomp the actual write times and access times, which is actually pretty clever. Not many ransomware do that. In fact, maybe less a handful. The actual code is actually pretty easy. If you know code, don't worry about it. But I'm looking at this routine here, this little caret. That caret equals. XOR encryption is not even encryption in a way. It's like lazy man's encryption. If you ever looked in the cryptology, it's a requirement for every type of crypto out there, but it's like at the very basic level. The idea with XOR is that it's literally a binary XOR, 1 and 0, 1 XOR 0, and so forth. An XOR works on what we call deltas. So you have an encrypted value, you have a plain text original value, and you have a key. So if you take your plain text and you XOR it by the key, you get the encrypted value. But it actually works in all the other ways too. If you have the encrypted value and you XOR it by that key, you get the regular value. So you can do cool stuff with that. It's actually called XOR crib dragging. That's the actual word. No one ever calls it that, but that's the technical word for it. Where if you don't know the key, but you have the encrypted file and you have the original file, that will tell you the key. Just XOR the two against each other and it outputs the key. And then you can use that to decrypt all the rest of your files on your hard drive. It's actually pretty easy. In this case, even if you don't have the key that's built in, and this one's actually on the screen, I'll tell you what it is. This one actually goes out to the website, it generates a URI, sends it to the website and says, hey, I'm checking in, I'm a brand new infected box. It'll send back an actual key value to use for encryption. So even though you don't know that key, if you have a copy of original and an encrypted value, you can just XOR them together and you got your key and then just apply to everything else. Junior developers and programmers can do that in like half an hour, as long as they know exactly what they're looking at. And this is actually, again, the same routine. So code, don't need to worry about this, but just to show you if you are a programmer, this is really all it's doing is one byte at a time, XOR and an output. Very simple and very stupid, but it works. It does just enough of the job to be effective. But then you have some of them that actually do real encryption, as they do AES, they do private keys, they do all that fun stuff, which I love this guy, Jigsaw. Jigsaw is actually a pretty wide family, very prevalent. They've been around for years. They actually have lots of different campaigns. Now, it's based off the Saw movie, so you actually have the little guy here who says, hey, we're going to play a game. Let's play a game. The idea is like every 24 hours, or every hour, I'm going to delete a random file off your hard drive until you pay the ransom. So it encrypts everything, and then it just starts randomly deleting things until you actually pay. And it actually does delete. This is actually real legit. They have other variants of this. They made a very hardcore pornography version of ransomware that they put up on fake porn sites, and they try to attack people that way, which was very effective. This guy, though, it actually uses AES encryption. However, it puts the actual password and initialization vector in the code itself. So you don't even have to be a reverse engineer. If you download this free tool and you throw the binary at it, it's going to just dump this code out to you. And you can look at it, it's like, oh, look, that's AES. Oh, look, it's this. You can literally copy paste this into your own program and just write the reverse of it and get all your files back. Which is actually what we do when we do IR. We're like, let me look at the sample. Oh, yeah, we can do this. When you look at like Kaspersky and all these other websites that have, oh, we have free decryptors that you can actually download if we know your family, that's all they're doing. They know the code, they know what's built into it, and they just write the decryptor based off that. You can actually do the same if you have some basic programming chops. Something simple. Now, again, code, Rijendell, this is AES encryption. In this case, what we're seeing, this is something called crypt console, is basic stuff. It's making a key, it's making an IV, it's encrypting data, it's the stuff we expect. And we look at the main. I'm going to just show a few things here because there's a lot of text. One, it generates a key, right? So it generates a second key, so your encryption keys together. And then save file with key. So it jumps into a file, okay? And then it starts doing encryption and get the folder path, it goes on network and does all the fun stuff. Get network computers and actually maps out to network shares and encrypts. That can't be right. Save file to a key. What does that actually mean? Take the key, take the vector, drop it to your desktop as program ID-LAN, and just write it. So it's actually creating a random key, an IV for encryption, and writing it to a text file on your desktop. Like, seriously. Like, you actually have everything in front of you to get your data back without paying the ransom. They left it there, I don't know, at their own convenience. Maybe that was the bug code they forgot to take out. But this was actually in the wild, and you look at it, it's like, that's simple. That's actually really funny. That level of ineptitude to developing and coding is awesome. We leverage that, we exploit it. I hope they keep this up. And we love it, hidden tiers. I love hidden tier. Hidden tier is an open source ransomware that was put out in GitHub about 3 years ago, and everyone uses it. If you have a script kid who actually wants to learn ransomware, they use hidden tiers. To the point where this awesome sample came out yesterday or the day before. It's called Ops Venezuela, and it was quickly called out on the internet. And give you an example. Over the left-hand side, you see the GitHub content. This is actually how the original source code was. I'm just going to show you one thing on here. Password equals create password 15. So they have a routine that says create password 15 bytes long, and it just returns back a password. And do all this other fun stuff, send a password, encrypt, and so forth. This is how they wrote this week. Password equals, quote, create password 15. That doesn't work the way you think it works. So instead of being a randomly generated key, the key is literally create password 15. Like, that is awesome. I mean, A for effort-ish. This is the stuff that actually goes along in the wild, and I love this. In fact, I think, yeah, here we go. It's actually zoomed in, so it's easier to read. That's how they should have been writing it. This is how they actually wrote it, in quotes. This is the level of adversary that I love. This is what makes their job fun on a given day. Oh, this guy. We have ransomware attacks documents, they attack JPEGs, they attack your movies, your family backups, and they attack your kid's Roblox game. That's all this thing does. You guys know what Roblox is, you have kids? Yes, apparently 60 million players. It's like one of the largest online games. So someone wrote an awesome ransomware about that targets specifically Roblox. That's sad. I mean, that's really just mean at this point. And it was real. When it runs, it drops a bunch of files, including this batch file. And this batch file, which is actually nice, cleanly written, I'm a good batch connoisseur, does target these extensions, Lua and these Roblox files. It drops a file called runtime, and it runs it against all of them. What runtime is actually just a command line AES encryption tool. You can just download off the internet. So basically, all they're doing is for every one of these files, AES encrypt, -E encrypt, -P the password of apples. And once they encrypt it, they start deleting the originals. So yes, it actually, and then it melts itself down here at the bottom. It works, it actually encrypts, it does some damage, but like seriously folks, like the tools are right there in front of you. You can just say, okay, even if I don't know exactly what this is, someone can look at this like, oh, I say yes, here, you can download the same tool, you can download anything, the password's sitting right in front of you. It's inside the file, and that's what we target. Love it. Even better is it when you actually do have the code you put in. So, you know, it gave you this box. You have to email them and get the code to put in there. If you actually look at the code, the password is poo-poo. So, usually in these cases is somewhat very targeted. Like they are actually targeting an actual person with this that they know won't be able to do this. This is not something like in the email campaign. This is proof of concept. It's targeting an actual small group of people. We see this a lot on hack forums or sites like that where people want to go on and download games and so forth. And you actually literally say, oh, look, I'll write a cheat for you. I'll write a trainer for you. Here, just download this. And they target kids who are online downloading cheats. So that's literally how this stuff comes about and how it gets into systems. But now let's talk about the enterprise side of this. Can we do the same? SamSam. Oh, I love SamSam. It's one of my favorites. If you don't know what SamSam is, it's just a quick briefer up here, which is very much one of the more advanced versions of ransomware out there, not just by the software, but how they use it. This is an adversary that actually uses live hands-on actions to infect your network. They will get in through an open RDP. If they don't have that, they will start doing network scans across all your open IPs. I did an IR, led an IR about a year and a half, 2 years ago, where they used Windshock. They found a Windshock vulnerability in IAS server on a box that the company forgot they had, and used that to get in. And once they got in there, they were able to pull down Mimikatz, they would pull all the tools in, move around laterally a little bit to get around, until they found a box that had a lot of activity on it, and they just sat there and waited for a domain admin to log in. And who was also our point of contact for the IR, so he was not happy when we told him it was his account that did all the damage. And once they had that, they actually used PowerShell to deploy the ransomware out and execute it. So they make XML files on their home machine. They upload it per box. So every single box they're going to infect has its own XML file. An XML file has a private key and so forth in it, public key. The idea behind that is you don't buy a single key to unlock your environment. You buy a key to unlock that box. And you have to buy another key to unlock that box. So they get you on a per box basis. And that's how they rack up the money. This is what hit the city of Atlanta a few months ago. This is what hit a lot of major organizations. These guys are good too. They actually target individual industries at any given time. So they would target like small electrical companies, they would target utilities, they would target, I'll give too close to the actual victim if I say, but they do go down these lines of like over a 3-month period going after very small specific industries. Now, it is actual real ransomware. It actually is productive. Twice we've been called in doing IR in my former role. One is where they didn't want to pay. We're like, no, too bad, you're not getting your data back. Sorry, we can't undo this. Second one is they paid, they got the decryption key, but they didn't feel like they could trust it. I'm like, well, why'd you pay then? They're like, well, can you just reverse it and figure out what it does and you write your own tool? Like, all right, we did this. Like, no, this tool works. Just use it. I'm not. You can bill. I'll bill you 100 hours if you want to write you a new tool, but this one works. The third one, which I'm going to bring up on the next slide, is they downloaded the tool, they paid for it, they got it, and it didn't work. it worked to a point, but all their major databases that the entire company relied upon were gone, were not being able to be decrypted. And so people start going out to sites like Bleeping Computer and saying, oh my God, I bought this downloading tool and it's not working. And enough people went back and forth to a point where someone was able to fix it with a little bit of help to determine what the problem was. And basically it was an issue of files over 300 megabytes. The way it did math and the offsetting of encryption just broke. They just didn't account for sizes of that big. So it will decrypt any size file under 300 megabytes. Over that, it didn't decrypt at all. So yeah, that was actually a wasted lot of money on these people. However, they were able to reach out, and the people from SamSam do actually monitor these forums and do give tech support. And I don't have the screenshot on me, but they made an updated version of the decryptor and provided it back to the customer, who was able to get their files back. It took about 6 weeks or 6 to 8 weeks, but they eventually did get it. So a lot of lessons there. SamSam itself has a lot of code issues. We had a great, when we were looking through this, we had one awesome box where we had 500 machines infected. This one was not. Like, all right, that's weird. We looked at the actual forensic history and we see the encrypted files, but then they're all deleted. Like, all right, so you guys recovered the box. Like, no, we didn't touch that thing. That's as it was during the attack. So what we knew was that SamSam creates this XML, it puts it into the root directory, and it uses that. What we found out was that somehow, as it was being read to the hard drive, the XML file got slightly corrupted, like a byte got dropped. I don't know how that happens, but that wasn't being read as actual XML anymore. Now, the bad error code collection or exception handling allowed SamSam to do this really funny thing where it would encrypt the file up here before it gets to this part of code, and then after it encrypts the file, it'll check the XML to double check values, and if the key is not correct, it'll basically parse the XML. If it doesn't work, it will delete the encrypted value or encrypted file, and then it'll go to the next file. So basically what it did was 30,000 times over, took a file, encrypted it, checked the XML, failed, deleted the encrypted file, left the original, moved to the next file. No, that can't be. That's really bad code. Actually, here's it. If you know code, you know this, but basically all it does is run from XML strings, an API call inside .NET. So you feed it XML text, and it either passes or fails. So you usually, as a programmer, wrap something around that, say, oh, if it fails, then do this. If it passes, then do this. No, it just failed, and just failed ungracefully. So it wouldn't encrypt any files on that box, which is kind of awesome. So again, bad coding happens even on the most legitimate of things. I'm going to change gears here for a little bit because I'm going to get some more fun topics. We can't just drone on about these really bad mistakes all day. One, let's start with Nicolas Cage. Hero of mankind. And the idea of Bitcoin and the idea of ransom notes themselves and what that tells us about an adversary and all the fun stuff that goes on with the samples. Because we all know, okay, the most major versions out there of ransomware use Bitcoin. Everyone buys a Bitcoin. Everyone loves it, especially when it peaks and spikes up. And they ask for one Bitcoin, which is worth $10 yesterday, now $200 today, and tomorrow it'll be 10,000. The day after that it's $5. To the point where, as Andrew Case calls out, companies that bought Bitcoin last year in case of ransomware are seeing a 4x increase in the last 12 months. This is actually a thing. People are doing this. Like, okay, let's just have it in our back pocket so that whenever we get attacked, we could just pay it quickly and get our data back. But then they never got attacked. So that $8,000 or whatever $5,000 investment suddenly became $20,000, $25,000, and the admin's like, I'm just going to take a little bit off that. We paid $5,000, we still got $5,000 there. But that was a very interesting way of doing it, especially with the way Bitcoin was. That now ransomware is moving beyond that. GandCrab came out February or January. It started using Dash, which is a fairly new one. There's ones out there for Ethereum. There's ones out there for Monero. Then you got this guy. This is actual MBR locker variant that overwrites the MBR. That's basically all it does, is it overwrites the MBR and puts a ransom note into the MBR. So you can't get back to your box anymore. However, this is literally the whole thing. So one, I see QQ, which makes me think, okay, Chinese, that's their major social network. Because this is in the MBR, it's in ASCII mode, you can't use Unicode characters. So they use what's called pinyin, which is basically Romanized, Chinese. Basically says, if you want your data back, send 30 yuan to this QQ. Anyone know how much yuan is worth? That's $5. So here's something very targeted. But really, it's just a funny example of the weird things we saw going through all this. Is this guy wanted $5 sent to his Chinese account. However, the MBR was overwritten, and they didn't save a backup of it. So I don't know how they're going to get the data back. And then you think, okay, we got all these various new Bitcoin variants coming out, we got all these new things. And that's what led into this awesome guy here, SpriteCoin. Great currency, because it doesn't exist. This was a brand new mining software for SpriteCoin. He was like, oh, wow, there's a new currency. Get it on the ground floor, get it while it's cheap. Except it doesn't exist. You create your wallet. It mixes little progress bars and does all that. It's actually encrypting your box. It's actually ransomware pretending to be a wallet and a miner, which is just genius on so many levels. I love it. Now, that level itself gets into what we call a variant called Black Ruby. Black Ruby came out earlier this year. Code, I'll explain this really quickly to you. The big parts here, mutexes, don't need to worry about that. This one, I'll come back to a little bit, talk about spycraft a little bit. But down here, it's going to entrench itself into the registry. It's going to then download and run a crypto miner. So what it eventually gets down to is there's here at the very bottom where it installs itself, it encrypts all your files, and then runs a crypto miner. So that encrypts your data as ransomware would, and just to pour salt on that wound, it's now using your box as a crypto mining as well. Because what are you going to do? You're going to turn your machine off? No, you're not. You're going to leave it going. And it's going to sit there for at least a few days while you try to figure out, what do I do with this? So that's a few days of uninterrupted crypto mining from your box. And they can just spike the CPU as much as they want at that point. Like, what are you going to do? They also have some really mean jerk things they do. So I talked about Samsung where over 300 megabytes it wasn't able to decrypt. Apparently they ran into some sort of similar issue because their code checks, okay, if it's a file extension, if it's under 512 megabytes and this and this and this, encrypt it. If it's over 512 megabytes and it doesn't end with BKF, which is the encrypted ransomware extension, delete it. My God, ow! That is a jerk move. So yeah, they don't even want to deal with files that big. They just delete it off your hard drive. So even if you paid the money to get it back, you're not getting it back. Now, the good spin on this is that we're here for spycraft. That's our overall theme this year, right? What happens here for Iranian? This machine, before it does anything, this ransomware will actually do a GeoIP lookup on your IP address. If you're based out of Iran, it will just quit. Anywhere else in the world, it will infect you. But Iran, no. You guys are good. That's what we're saying. And they're not the only one to do that. This was a campaign of, I can't remember the name off the top of my head, but basically they had a Taiwanese campaign of ransomware. And this victim emailed out, and the victim actually shared this email to Taiwanese news. And basically the victim says, my monthly income is only $400. You really want to do this on me? Legitimate. Most ransomware do have support. They can work with you, negotiate. Very well-fractured English here of, no, we don't. Frankly, the campaign seems to be a total failure. Apparently, we have largely overestimated the income of the population of your country. Wow. It's like a backhanded compliment here. Wow. What does that say about your country? So, okay, you don't have to pay now. We've switched Thundercrypt to decryption mode. Thundercrypt, that's what it's called. So basically, here's your data back. basically at that point. Like, me as a poor college student, whatever, I can't pay, they'll work with you if you're not American. You know, screw America. Like, if you try to support or try to you know, get the value down, no, they'll raise it up. Most other countries, though, they have some sympathy for you. Not just Taiwan. I love this guy. This is a SIG run, but this came out in the last 2 days here. Of basically the people who run SIG run had some emails sent, people asking you like, hey, how do I get my money? How do I pay this? What do I need to do? One guy asked, how much money does it cost in dollars? And they're like, 2,500. This guy asks, how many rubles must I pay? At bottom, I know it's out the bottom screen, but you do not have to pay, I'll just help you. Keyword, rubles. Russian. As soon as you said that keyword, like, gotcha, bro. Really, that's a thing. And even more so, when you look at the actual code of that, this is actually what it looks like in the reverse engineer code, is open up the registry, go to keyboard layout, preload, check the value against 419. 419 being the Russian keyboard layout. If you have a local keyword in a Russian layout, it will not infect you. It will just move on. What this one victim got was that he was using a US computer laptop, and so he did get infected. But he's like, no, I'm Russian, and got his data back. So when you get to that point, how do you tell the difference between a real and a not real threat? Like, if someone sends you like, hey, you need to be afraid of this, like, yeah, that doesn't exist. That's not a real thing. Gears of War, though, they pulled it off. How do you do that? One is the online tools out there. Got my timing off a little bit there. One is the ID Ransomware by Malware Hunter team. They have this nice little service here. Another one is ID Ransomware on Amigo. He's a Russian analyst. He puts all the new samples up on his blog post. They're in Russian, but you can convert them over to English. It actually works out really well. He's got some really good details on them. The great thing about Malware Hunter team is that, for example, this one, ignore the red bar. You can go to the service, upload the actual copy of the ransom note, and they can look at that and say, okay, we know exactly what you're infected with. In this version, it was Kirk. This is actually Kirkware, as in Star Trek Captain Kirk. So when you run it, it pops up a text box and actually shows Spock and Captain Kirk in ASCII art, and then starts infecting all your files. Great piece of art. There's no way of getting that data back. However, they now tell you, currently there's no way of getting your data back, but we know in the future, eventually these campaigns run out, and adversaries are like, yeah, okay, I've just give them all the data back. We don't want to deal with this anymore. Like, they've moved on to something else. So they will just put the keys out there publicly. It's happened in at least 5 campaigns I know of. So these guys will track that, like, hey, we actually have the keys now. Let's email all these people who have files encrypted and let them know they can get their data back. Which is why we tell victims, don't just give up and wipe your box just because you can't get your data back. Back up the encrypted files and then wipe your box. Because eventually you may get the key to get your data back from them. Again, basic information that we tell you, we don't need to go into some too much detail. These are kind of the basics that people should know about dealing with ransomware is have backups, have the ability to do root cause analysis, which is always the single lacking point on almost everything, is that we don't know how we got infected, but we got 500 machines destroying themselves right now. Like, how would you not know that? We think it's email, but maybe it could be someone's download folder. How do you do your job and not be able to turn that granular level of how did I get infected? In many cases, people can't. So it's like, okay, have something out there. Have an email, just checklist. Look through forensic timelines. Okay, the first box started encrypting at 8:04 a.m. What emails came in maybe just a few seconds prior to that? Maybe those were related. Typically, that's what it is. We also tell people you can just do a minimal analysis before you call in IR, call in forensics, call in security teams and pay $400 an hour for someone to kind of walk through and do what you can do for free. One of it is just very basically if you can identify what variant of the ransomware it is, even using one of these sites, one of these 2 websites, that would get you a long way there. Upload your ransom note, figure out what it is, And it really quickly will tell you, okay, either you're screwed or there's hope for you. And then based off that, you can determine, okay, do we need to call in IR? Do we need to call in security teams and work us through this? But the tools out there that we use for analysis are actually pretty basic and open source and free. So if you see ransomware, it's almost always .NET. And so there's a tool called DNSpy, which is .NET Spy, that you can just download for free and just throw software at it, and it'll just vomit open code at you that's actually easy to read and easy to understand. Give that to a junior analyst who's someone who's like just knows programming, went to college, and they can whip out a decryptor for you. In many cases, it's just doing string analysis. This was a version of JF ransomware where it asked for an unlock code. The code was actually hard-coded into the binary itself. And using a tool called Floss, which is from FireEye's Flare team, which is an awesome tool. If you use strings a lot, use Floss instead. Floss gives you ASCII and Unicode very cleanly, and it also does stack strings, which I won't explain here, but they're really awesome. Basically obfuscated strings it can pull out. But in this case, that was the actual password to decrypt this machine. It was just basically sitting there right there in the file itself. Which leads to, on the forensic side, we do this a lot. If we have encrypted files, we have passwords, we will run strings on an entire hard drive image, dump it out to a major file, and then try all of them one after another until something works. Because somewhere on that hard drive is the password, either in volatile memory or in a disk slack or something. Same way here. If you have an unlock code, it's probably somewhere on that side executable. And in cases like that, that simple string, dump it out, throw it in the program, you get this nice big unlock button, and you get your machine back. And with that, thank you. Any questions while we're here? Actually, is it on time? Yeah. Like, what are the odds of getting an actual real ransomware versus?
Yeah, versus like versus CircleCity stuff.
All right, so what's the odds of actually having a real ransomware versus a CircleCity one? Predominantly, you're going to see the real ones more often. You're going to see the ones like Verilog or TeslaCrypt, all those ones quite often. However, they're very targeted in where they attack. You know, either enterprise certain victims and have very specific email campaigns, whereas these CryptKitty ones are very prominent on like hack forums and websites and forums, or people actually using Steam to infect each other in chat rooms, which actually they pretend to be someone working for Steam and like, hey, run this program, it helps us get your stuff back. It's ransomware. So you'll see the CryptKitty on that side more often, the commodity side. Thank you. Questions? All right, thank you very much.